Recent and comprehensive preparation materials are available for the following California license exams: Law, Business and Trade, specifically the C10 Electrical Contractor exam. The materials include information books, example exam question books, and audio tapes and CD for convenient study. Take advantage of these resources to enhance your preparation and increase your chances of exam success. Contact information email. Don't miss out on this exceptional opportunity to secure your study materials at a competitive price. When preparing for an electrical contractor's license exam, it's important to focus on several key areas. Firstly, you need a strong understanding of the National Electrical Code, or NEC. This code provides the standards for safe electrical installations. Familiarize yourself with the articles and sections that are most relevant to residential, commercial, and industrial electrical work. Secondly, study electrical theory. This includes concepts such as Ohm's law, which states that voltage equals current times resistance, or volts equals amps times ohms. Understand series and parallel circuits, AC and DC circuits, and how to calculate power, voltage, current, and resistance in various circuit configurations. Thirdly, learn about electrical components. Become proficient in identifying and understanding the function of various components such as resistors, capacitors, inductors, transformers, and diodes. Also, study different types of wiring, including their ampacity and appropriate uses. Fourthly, review electrical safety practices. Safety is paramount in electrical work. Learn about grounding and bonding, GFCI protection, arc flash hazards, and lockout-tagout procedures. Understand the importance of personal protective equipment, or PPE, and safe work practices. Fifthly, study motor controls. This includes understanding different types of motors, motor starters, overload protection, and variable frequency drives, or VFDs. Learn about motor control circuits and how to troubleshoot motor control systems. Sixthly, familiarize yourself with the California Electrical Code, or SEC. While the NEC forms the basis for electrical installations, California may have additional or modified requirements. Understand any state-specific regulations and amendments to the NEC. Seventhly, practice with example exam questions. Work through as many practice questions as possible to familiarize yourself with the format and content of the exam. Identify your weak areas and focus your study efforts accordingly. Eighthly, consider using study aids such as textbooks, online courses, and practice exams. Many resources are available to help you prepare for the electrical contractor's license exam. Choose the resources that best suit your learning style and needs. Ninthly, review blueprint reading. Being able to interpret electrical blueprints is essential for electrical contractors. Learn how to identify electrical symbols, understand wiring diagrams, and interpret specifications. Tenthly, understand business law and project management. In addition to technical knowledge, electrical contractors need to understand business law, contract law, and project management principles. Study relevant laws and regulations, contract negotiation, and project scheduling. To elaborate on the NEC, it's crucial to understand its structure and how to navigate it effectively. The NEC is organized into chapters, articles, and sections, each covering specific aspects of electrical installations. Chapter 1 contains general information and definitions. Chapters 2 through 7 cover specific requirements for wiring and protection, wiring methods and materials, equipment for general use, special occupancies, special equipment, and special conditions. Chapter 8 covers communications systems. Chapter 9 contains tables and examples. When using the NEC, it's important to understand the definitions of key terms. The NEC defines many terms that are specific to electrical installations, such as ampacity, voltage drop, grounding, and bonding. Understanding these definitions is essential for interpreting and applying the code correctly. The NEC also includes numerous tables that provide information on conductor ampacity, conduit fill, box fill, and other important parameters. These tables are essential for ensuring that electrical installations comply with the code. For example, Table 310.16 in the NEC provides the allowable ampacities of insulated conductors rated up to 600 volts, based on their insulation type and ambient temperature. It's important to select conductors with sufficient ampacity to carry the intended load without overheating. The NEC also specifies requirements for overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. The NEC specifies the maximum allowable overcurrent protection for different types of circuits and equipment. For example, Section 240.4 in the NEC specifies the overcurrent protection requirements for conductors. In addition to overcurrent protection, the NEC also requires grounding and bonding of electrical systems. Grounding is the connection of electrical equipment to the earth, while bonding is the connection of metallic parts of an electrical system to create a low impedance path for fault current. Grounding and bonding are essential for safety, as they help to prevent electrical shock hazards. The NEC also includes requirements for wiring methods and materials. Wiring methods refer to the way in which electrical conductors are installed, such as in conduit, cable trays, or direct burial. The NEC specifies the types of wiring methods that are permitted for different applications. The NEC also specifies the types of materials that are permitted for use in electrical installations, such as conductors, insulation, and enclosures. It's important to use materials that are listed and labeled for their intended use. In addition to general requirements, the NEC also includes specific requirements for special occupancies, such as hazardous locations, healthcare facilities, and places of assembly. These occupancies have unique electrical requirements due to the increased risk of fire, explosion, or electrical shock. The NEC also includes specific requirements for special equipment such as elevators, escalators, and swimming pools. This equipment has unique electrical requirements due to its specific function and operating conditions. When studying electrical theory, it's important to understand the relationship between voltage, current, and resistance. Ohm's law states that voltage equals current times resistance. This law is fundamental to understanding how electrical circuits work. Voltage is the electrical potential difference between 2 points in a circuit. It is measured in volts. Current is the flow of electrical charge through a circuit. It is measured in amps. Resistance is the opposition to the flow of current in a circuit. It is measured in ohms. In addition to Ohm's law, it's also important to understand the concepts of series and parallel circuits. In a series circuit, the components are connected end to end, so the same current flows through all of the components. In a parallel circuit, the components are connected side by side, so the voltage is the same across all of the components. The total resistance of a series circuit is the sum of the individual resistances. The total resistance of a parallel circuit is calculated using the following formula: 1 divided by the total resistance equals 1 divided by resistance 1 plus 1 divided by resistance 2 plus 1 divided by resistance 3, and so on. It's also important to understand the difference between AC and DC circuits. DC, or direct current, is a type of electrical current that flows in one direction only. AC, or alternating current, is a type of electrical current that reverses direction periodically. AC is the type of electrical current that is used in most homes and businesses. The frequency of AC is measured in hertz, which is the number of cycles per second. In the United States, the standard frequency of AC is 60 Hz. When studying electrical components, it's important to understand their function and how they are used in electrical circuits. Resistors are components that oppose the flow of current. They are used to limit current, divide voltage, and provide a load for a circuit. Capacitors are components that store electrical energy. They are used to filter noise, smooth voltage, and store energy for later use. Inductors are components that store energy in a magnetic field. They are used to filter noise, store energy, and create oscillators. Transformers are components that transfer electrical energy from one circuit to another. They are used to step up or step down voltage, isolate circuits, and match impedance. Diodes are components that allow current to flow in one direction only. They are used to rectify AC voltage, protect circuits from reverse voltage, and create logic circuits. In addition to understanding electrical components, it's also important to understand different types of wiring. Conductors are the wires that carry electrical current. They are typically made of copper or aluminum. Insulation is the material that surrounds the conductors and prevents them from shorting out. The ampacity of a conductor is the maximum amount of current that it can carry safely. The ampacity of a conductor depends on its size, insulation type, and ambient temperature. The NEC provides tables that list the ampacity of different types of conductors. When selecting conductors, it's important to choose conductors with sufficient ampacity to carry the intended load without overheating. It's also important to choose conductors that are suitable for the environment in which they will be installed. For example, conductors that are installed in wet locations must be rated for wet locations. When reviewing electrical safety practices, it's important to understand the hazards of electricity and how to protect yourself from them. Electricity can cause burns, shocks, and even death. It's important to follow safe work practices and use personal protective equipment, or PPE, when working with electricity. Grounding and bonding are essential for safety. Grounding is the connection of electrical equipment to the earth, while bonding is the connection of metallic parts of an electrical system to create a low impedance path for fault current. Grounding and bonding help to prevent electrical shock hazards by providing a path for fault current to flow back to the source, tripping the overcurrent protection device. GFCI, or ground fault circuit interrupter, protection is required in many locations where there is a risk of electrical shock, such as bathrooms, kitchens, and outdoor areas. A GFCI is a device that detects ground faults and interrupts the circuit, preventing electrical shock. Arc flash hazards are another important safety concern. An arc flash is a dangerous electrical explosion that can occur when there is a short circuit in electrical equipment. Arc flashes can cause severe burns, injuries, and even death. It's important to wear appropriate PPE, such as arc-rated clothing and face shields, when working on or near energized electrical equipment. Lockout-tagout procedures are used to prevent accidental energization of electrical equipment during maintenance or repair. Lockout-tagout involves disconnecting the equipment from its power source and attaching a lock and tag to the disconnect device, indicating that the equipment is out of service. When studying motor controls, it's important to understand different types of motors, motor starters, and overload protection. Motors are used to convert electrical energy into mechanical energy. There are many different types of motors, such as AC motors, DC motors, and synchronous motors. Motor starters are used to start and stop motors. There are many different types of motor starters, such as across-the-line starters, reduced voltage starters, and variable frequency drives, or VFDs. Overload protection is used to protect motors from overheating. Overload protection devices, such as thermal overloads and electronic overloads, are designed to trip the motor starter if the motor draws too much current. Variable frequency drives, or VFDs, are used to control the speed of AC motors. VFD work by varying the frequency of the voltage supplied to the motor. This allows the motor to operate at different speeds, which can save energy and improve performance. When familiarizing yourself with the California Electrical Code, or SEC, it's important to understand that it is based on the NEC, but it may have additional or modified requirements. The CC is updated every 3 years in conjunction with the NEC. It's important to stay up to date on the latest edition of the CC to ensure that your electrical installations comply with the code. The CC may have specific requirements for certain types of electrical installations, such as solar photovoltaic systems, wind turbines, and electric vehicle charging stations. It's important to research these specific requirements before installing these types of systems. The CC also includes requirements for permitting and inspection of electrical work. In California, electrical work typically requires a permit from the local building department. The building department will inspect the electrical work to ensure that it complies with the CEC. When practicing with example exam questions, it's important to work through as many questions as possible to familiarize yourself with the format and content of the exam. Pay attention to the wording of the questions and the answer choices. Some questions may be tricky or ambiguous, so it's important to read the questions carefully and choose the best answer. After completing a practice exam, review your answers and identify your weak areas. Focus your study efforts on these areas to improve your knowledge and skills. Consider using study aids such as textbooks, online courses, and practice exams to help you prepare for the electrical contractor's license exam. Many resources are available to help you prepare, so choose the resources that best suit your learning style and needs. Some popular textbooks for electrical contractors include Electrical Wiring Residential by Ray C. Mullen, Electrical Wiring Commercial by Ray C. Mullen, and NFPA 70 National Electrical Code. There are also many online courses available that cover the material that is tested on the electrical contractor's license exam. Some popular online courses include those offered by Michael Enterprises and the International Association of Electrical Inspectors, or IAE. In addition to textbooks and online courses, there are also many practice exams available that can help you prepare for the electrical contractor's license exam. These practice exams can help you identify your weak areas and get a feel for the format and content of the exam. When reviewing blueprint reading, it's important to be able to identify electrical symbols, understand wiring diagrams, and interpret specifications. Electrical symbols are used to represent different electrical components on blueprints. It's important to be able to identify these symbols so that you can understand the electrical system that is being depicted. Wiring diagrams are used to show how the different electrical components are connected. It's important to be able to understand wiring diagrams so that you can install and troubleshoot electrical systems. Specifications are written documents that provide detailed information about the electrical system, such as the types of materials that are to be used, the installation methods that are to be followed, and the testing requirements that are to be met. It's important to be able to interpret specifications so that you can ensure that the electrical system is installed correctly. When understanding business law and project management, it's important to study relevant laws and regulations, contract negotiation, and project scheduling. Electrical contractors need to understand business law, contract law, and project management principles in order to run a successful business. Business law covers topics such as business formation, business licensing, and business taxes. Contract law covers topics such as contract formation, contract interpretation, and contract enforcement. Project management covers topics such as project planning, project scheduling, and project cost control. It's important to understand these concepts so that you can manage your projects effectively and avoid legal problems. In summary, preparing for the California Electrical Contractor's License exam requires a comprehensive understanding of the National Electrical Code, electrical theory, electrical components, electrical safety practices, motor controls, the California Electrical Code, blueprint reading, business law, and project management. By studying these topics and practicing with example exam questions, you can increase your chances of success on the exam.